Let R of x, C of x, and P of x be, respectively, the revenue, cost, and profit in dollars from the production and sale of x items. If R of x equals 5x and C of x equals 0.001 x squared plus 1.2 x plus 60, find each of the following. We're going to begin by finding P of x, which is the profit function. Now recall that we can find the profit function by taking the revenue function, R of x, and subtracting from that the cost. So profit is calculated by taking revenue and subtracting off the cost. So here we have the revenue function, which is 5x, and we're going to subtract from that the cost function. So we're subtracting off 0.001 x squared plus 1.2x plus 60. Now when we simplify this, we're going to have a negative 0.001 x squared. Then we have a 5x minus 1.2x to give us a plus 3.8x, and then minus 60. So that is our profit function for part A. In part B, we want to find R of 100, C of 100, and P of 100. So when X items are produced and sold, what is the revenue from that? So we're plugging 100 into the revenue function. So we have 5 times 100, so we get 500. And since revenue, cost, and profit is in dollars, then our answer here would be $500. Now the cost. So what is the cost of production and sale of 100 items? So we're plugging 100 into the cost function. So we have 0.001 times 100 squared plus 1.2 times 100 plus 60. This simplifies to give us 190. So here our answer is $190 for the cost of producing and selling 100 items. Now we're asked to find the profit for 100 items. So plugging that into the profit function, we have a negative 0.001 times 100 squared plus 3.8 times 100 minus 60, which simplifies to give us $310 as our profit from 100 items. Also notice how if we look at what our revenue answer was and our cost answer, if we take revenue and subtract from the revenue the cost, so 500 minus 190 also gives us the profit of 310. And we said that back here in the beginning, that profit is equal to revenue minus cost. Next we want to calculate the derivatives of the revenue, cost, and profit function. And the reason that we're interested in the derivatives is because these are the marginal revenue, cost, and profit. So for example, when we calculate R prime of x, the derivative of revenue, that is the marginal revenue. So this gives us an approximation for the revenue from the x plus first item. Our revenue function was 5x, so taking the derivative of 5x is 5. Next, calculating c prime of x, the derivative of the cost function, comes out to be 0.002x plus 1.2. So there's our marginal cost. Next, let's calculate p prime of x. So taking the derivative of the profit function, we have a negative 0.002x plus 3.8. So this gives us the marginal profit, which would allow us to approximate the profit from the x plus first item. Next, we're going to calculate the marginal cost, marginal revenue, and marginal profit for 100 items. So using our derivatives here. So we begin by calculating R prime of 100. So plugging 100 into the derivative of the revenue here. Well, the derivative for revenue was 5. It was a constant. So what this tells us is that once 100 units have been produced, the approximate revenue of the 101st unit, which is the marginal revenue, is $5. So next let's calculate C prime of 100. So this is going to be the marginal cost at 100. So plugging 100 into the derivative, we have 0.002 times 100 plus 1.2, which comes out to be 1.4. So the way we would interpret this is that once 100 units have been made, the approximate cost of the 101st unit, which is the marginal cost, would be $1.40. Next, let's calculate the marginal profit at 100. So plugging 100 into the first derivative, we have a negative 0.002 times 100 plus 3.8, which comes out to be 3.6. So once 100 units have been made, the approximate profit of the 101st unit, which is the marginal profit, is $3.60. Now to calculate the marginal profit at 100, we used the first derivative and got $3.60. However, another way that you could have calculated this is since we already calculated the marginal revenue and we calculated the marginal cost, we could have simply subtracted those. So taking the 5 minus $1.40 gives us $3.60. So in part E, we're asked to describe what each quantity in parts B and D represent, and we kind of did this as we went along, but let's just kind of reiterate what we found. So in part B, we were using the revenue, cost, and profit function, and we calculated revenue, profit, and cost for 100 units. So the total revenue from the sale of the first 100 units is $500. The total cost of producing the first 100 units is $190. And then when we use the profit function, we calculated $310. There's a gain of $310 when 100 units are produced and sold. Also notice when we take revenue and subtract cost, we get the profit of $310. Then in part D, we use the derivatives to calculate marginal revenue, cost, and profit. So once 100 units have been made, the approximate revenue of the 101st unit, which is the marginal revenue, is $5. Once 100 units have been made, the approximate cost of the 101st unit, the marginal cost, is $1.40. And then once 100 units have been made, the approximate profit of the 101st unit, which is the marginal profit, is $3.60.